Okay, we're back going through the Common Core exams, New York State Geometry, and this one is the June 2016. Okay, so we'll start with number one. What we're doing here is one of those spatial reasoning problems where we rotate a 2D shape to try to, see what would we cut out with that. So basically what we have here is a piece of paper, rectangle, and we're going to rotate it around a folded side. So they're just trying to make it a little tricky here. So we're going to rotate it around. So this point's path is going to be a circle. Okay, it's going to end up all the way around and back. This space that it would carve out, if you do that with this as well, hopefully I can do a decent job with that. Okay, you can see the space that's going to carve out is going to look most like a cylinder. So that's what we're going to go with there. This is a spatial reasoning. You're trying to imagine what's going to happen, in a 3D space. Not easy to do. All right, so we have, I'm going to dilate a segment. In the center is on the midpoint. So we got a segment, call it AB, and we're going to dilate with a center right at the midpoint here. Call it M. All right, so if it's 3 inches, we got 1.5 on each side. And how it's going to work is, B is going to be 6 times, B prime, I should say, is going to be 6 times as far from M as B is. So we're going to take that space, and it's going to be a total of 9 for B prime. And A is going to go the same amount over this way. Okay, so that's going to be all the way back to 9. Now, it doesn't just pick up at here and go 9. It goes back to the center and goes 9. So 9 plus 9 is 18. We could have just done, 6 times 3 is 18. That would have worked as well. All right, number 3. This is kind of a different format than the one we teach, but this is completing the square. We're shooting for this format here, x minus h squared plus y minus k squared equals r squared. That's our goal. That's going to be the circle equation that we like for the center radius form. So what we're trying to do is locate an error in this person's work. So we're evaluating other students' work. Okay. So if you had x squared plus 4x, I'd probably want to create a space here because we're going to complete the square. On the left side, while we're doing that, we'll probably distribute that negative. So we got negative y squared plus 20. And yeah, so they just distributed the negative there. That works. Okay, so now it's going to turn into that eventually. So I'm going to have to add in a 4. So whatever I add to the left, I'm going to add to the right. But they subtracted it over there. So we're not going to be able to do that. That's going to be the mistake. The rest of it, yep, that's good. Let's see. Oh, they're going to add, looks like they're adding y squared to both sides. Sorry about that. Get this out of the way. And the rest of it's fine. 20 plus 4 is 24, so that's what it should be. The error was back in, what did we say, step 2, so that's our choice. All right. Which transformation would result in an image parallel? Okay. Transformations that would give an image that's parallel. Well, what we know is, let's see, there's transformations that preserve slope. So parallel, we know, needs the same slope. Okay, so dilation, translation, and 180-degree rotations all preserve slope. So basically that's what we're looking for. Line reflection doesn't have to. It can at times, but it doesn't have to. You know, you can see right there, if we reflected over the y-axis, we'd lose the slope there, not parallel. So that's not going to do it. That's not going to do it. A 90-degree rotation is not going to do it. Translation is what we're looking for there. So good. Let's see, which cannot be proven similar. Okay. All right, here we go. So we get a pair of angles that are congruent. They're the included angles between these sides that they give us the measures for. So it's probably side angle side. Yeah, 12 over 4 is going to equal 9 over 3. Those cross products are both going to be 36. So that those are similar by side angle side. Oh, these are not going to be. So the angle needs to be the included angle, meaning between the sides that they give you the numbers for. Okay, so if we had any chance at this being proven similar, it would have to be these angles. And I still don't think we'd make it because those are not going to be proportional sides. That's a 8 to 1, that's 4 to 1. Just not going to happen. It's going to be that one that we cannot be. This one, these are going to be similar by angle, similar to postulate. And these are actually congruent by side angle side. So those are still similar. Congruents are still similar. So pretty good. All right, number 6. So we've got a cube and a cone that we're going to cut out of it. All right. We'll give it an attempt here. Okay, so we're going to try to cut out a cone. Not too bad. All right. Cube, what we have to know is length, width, and height are all the same in a cube. So they give us a length of 8.5, but that's all the dimensions. And let's see, we're cutting out an 8-centimeter diameter cone with an altitude of 8. Okay, so we're going to cut that out. What is remaining? Okay. Let's do, so volume of a cube is length times width times height, we know. The formula off the formula sheet is going to be capital B times H. That's area of the base. Simply 8.5 times 8.5 for that. And then another 8.5 for the height. Okay. The volume of the cone is that formula right off the formula sheet. Don't have to memorize it. Careful here, the radius though. Half of 8, which is 4. And don't forget to square that. That's easy to forget those things. So just be really cautious of that. Oh, looking at the choices over here. All right, yeah, we're going to subtract these, so perfect. This one's no good because it doesn't have the 1/3, neither is that. This one's no good because you squared the diameter, so it's going to be this one. All right. Now, two right triangles must be congruent if. All right. So an acute angle in each triangle is congruent. We could have, let's just do an easy 130. But then we could have a bigger triangle that has a 30. So that's not going to be enough. That's going to get us similar, not congruent. That's what we're after. Lengths of hypotenuse equal. I don't think so. I mean, that's, if you think about it, just that, we know is not enough information. We need a pair of legs, you know, for HL or side angle side. Just hypotenuse, not going to be enough. Okay. Corresponding legs. Now, if that means both, let's see, both pairs of corresponding legs. Let's look at this set. Right triangle. And if they meet both pairs of corresponding legs, I guess, yeah, That's got to be the one. Areas equal, that's interesting. Um, we can come up with different areas. I'm sorry, the same area, but with different legs, meaning this. So I might go 5 and 12, or let's do 10 and 6. Those are going to have the same areas. Those are going to have areas of 30. 1 half times 5 times 12 is 30. 1 half times 6 times 10 is 30. But these are definitely not congruent triangles. So it's going to be choice 3. All right. Let's see. This one hopefully is obvious to you. Um, let's see. We know we need a dilation in there somehow because the figures are not the same size. So we're going to get rid of these. Um, you're going to need one of these combinations here. Now, we talked earlier about translations, um, preserving slope. Well, let's look right here. AB would be parallel to A prime B prime under a translation. They're not. So we didn't use a translation. We must have used a rotation, and it looks like that. We made it bigger, and then you'll definitely have to rotate. All right, number 9. Let's see. Okay, tricky problem. All right, parallelogram theorems or properties we get from this. Right, they're telling us it's a parallelogram, but essentially we want to say which one would upgrade it to a rhombus. Which one of these would, or which one would not upgrade it to a rhombus for sure? Which one would not? All right. So they're going to draw these in, intersect at E. So which property is not going to upgrade it to a rhombus? Let's write down what would upgrade a parallelogram to a rhombus. Diagonals bisecting each other would not, because a parallelogram already has that. To upgrade it, we got to do better. A rhombus needs diagonals to be perpendicular. It needs diagonals to bisect the angles. And then it needs all sides congruent. So that's what would upgrade it from a parallelogram to a rhombus. So let's just look at which ones those are. Okay. AB the same as BC. That would force all 4 sides the same. That takes care of that one. That's going to prove that it's a rhombus. Okay. Yep, there it is right there. The diagonal is perpendicular. That would prove a rhombus. Either diagonal bisecting the angle DCB, this one right here. If that happened, it would be a rhombus. You know, given that we started out with a parallelogram. Okay. Um, this one's not. Okay, we don't need congruent diagonals. That's what this is saying. Don't need congruent diagonals for a rhombus. We would need that for a rectangle. So there you go. Number 10, which is always true. BAC, that's an inscribed angle. And BOC is a central angle. They open up to the same arc or intercept the same arc, BC. They're not going to be equal. Okay, we can move on from there. BAC is half of BOC. That's actually true. All right, that's the one that's true. So, basically what's going to happen is, let's assume this is 50 for a second. For an inscribed angle, you would double the angle to get the arc that it opens up to. And then for the central angle, it's the same measure as the arc that it opens up to. So that's going to work right there. Half of angle BOC is the same as measure of angle BAC. Why aren't these going to work? All right. Well, chords don't have to be congruent. So this does not have to be isosceles. radii have to be the same, so that one's going to be isosceles, but not this one. And the area, I doubt it. Yeah, I really doubt that. Okay. Use the same base, possibly. Let's assume it's a right angle for a second. That versus that. Yeah, that's not going to be twice as big. It's actually more than twice as big. So, yeah, not going to do it. So choice 2. All right, next we have let's get a little space. We probably need some space in here. Yeah, probably going to be a Pythagorean theorem problem. That's or no, actually it's going to be a trig problem. There's an angle there. All right, 70-degree angle, 20-foot support post, leans up against the wall. All right, we want that height, and we want a 70-degree angle with the ground. All right, so we're going to go opposite 70, right? I like to label the sides here adjacent to the acute angle. This is going to be the hypotenuse because it's across or opposite the right angle. Write down an acronym to help you decide on which trig function to use. And it looks like we're going to be best with, oh, yeah, nothing with adjacent, so sine is going to have to work. Hopefully sine of 70 degrees will equal opposite over hypotenuse. Okay, so sine of 70 degrees, just type that into my calculator. It is 0.9396 to 1. I like to, show those as ratios. I like to tell students trig functions. Those are ratios of two sides. So if they give you one number, put it over 1. All right, now we'll cross multiply. H equals whatever 20 times that is. So that looks like 18.79. Okay, and we've got to round to the nearest tenth. Let's go kick it up to 18.8. All right, last one for this video session. Okay, for this one, personally, I would graph this. Just be careful. -11 would be off your typical graph. But if you go to the scrap graph paper on the Regents exam, you can move your axis over so you can cover that. I'll show you how to do it algebraically, but again, graphing's way better. What I would want to do is perpendicular bisector would have to hit the midpoint. Think about that. You've got, I'll just sketch it quick. -5, or -11, 5, and 5, -7. Somewhere in that range, okay? And what you're looking for is the midpoint. You're looking for this spot, or perpendicular bisector, you want to hit the midpoint to bisect. So I'm going to figure out the midpoint right there. I'll just call that M for midpoint. All right, what I tend to do if I'm doing it algebraically, I would add, then divide by 2 on the x's, and then divide by 2 on the y's. Let's see, that's -6, so it's going to be -6 over 2 is 3. -2 over 2 is -1. So I was off by a little bit, but that was a rough sketch. So, all right. So this is going to be a point that's on the line, on the perpendicular bisector. Now the next part is I would want to get the slope of NY. All right, I'll do this algebraically. If you did it graphically, it'd be a lot easier, but go ahead. So subtract the y's, subtract the x's. Looks like 12 over -16. I like to bring the negative up top, which you'll see in a second here, but let's take on a 4. So I got a negative 3/4. All right, now to get a perpendicular line, the slope will have to be the negative reciprocal of that. So flip it and change the sign. All right, so what I would do is probably, these are in point slope form. Great. We're used to slope intercept form, mx plus b, so they threw us a little curve. A couple ways you can handle this. If you like to graph, you could start at the m. You could go up 4, right 3, and you can find your y-intercept there. But then you got to convert all of these to y equals mx plus b. Point slope form looks like this. Y minus y1 equals mx minus x1. So they're kind of making it really tough if you don't teach point slope form, but we can handle it. Let's see. So what does that mean? That point that we put on here, basically they're saying that's x1 is negative 3, and y1 is negative 1. So y minus negative 1 is mx minus negative 3. Double negative, we'll get rid of that. Double negative, get rid of that. Oh, we need to put what m is. We calculated m earlier. For the perpendicular bisector is 4/3. So, is that one of the choices? Yes, it looks like choice 1. All right, that's it for this session. We'll pick up in the next one on number 13.